My name is Dan Taylor. I'm a senior program manager on the Azure Diagnostics team.
My name is Nikhil Joglaker. I'm a program manager on the Visual Studio team.
And today we're going to be sharing with you a lot of the great work that our teams have been collaborating on together to bring to you some really exciting diagnostic capabilities in Azure that helps you as developers and IT operations and DevOps quickly find and root cause issues that are in production so you guys can get your services up and running and healthier more quickly. So what does this talk about? Why are we talking about debugging in production and diagnostics in production? So increasingly, as we're moving to the cloud, there's this theme of being able to, it's all about agility. Developers want to move faster, deploy faster, and they're going to be deploying, because they're deploying faster, there's kind of this idea of move fast and break things. Just get it up there, see what breaks, and then we'll fix it. So that implies that you need to be able to actually root cause and fix these issues faster than you're creating them in production. So with this sort of increased trend, the importance of these tools, especially as you're moving to cloud, become more important. And this is the reason that we've built these capabilities and tools into the Azure environment to make it easy for you to do this work. And we're going to be talking about that today. So why is debugging in production or fixing issues in production so hard? Well, we've talked to a number of developers in Azure and Visual Studio, and we came up with some very common themes. So one of them is just overall frustration and with getting access to exceptions and logs data from production, right? Who's seen this? A developer has a bug. I got to file a ticket to get the logs to get for that bug. And then I open the log file, and it turns out the princess is in another castle, and I have to get a different set of log files because the problem was actually on a different server, right? And you kind of have to manually read through them and things like that. Or maybe you've invested in building a solution that allows you to send your log files all to a centralized place, and you have to maintain that and run that, and that's a whole other set of headaches. The issues themselves that happen in production can be caused by different configuration in the production environment or different data that's in the production environment that you might not have access to in your dev or QA environments. And there's also things that only happen at the scale that happens in production, whether it's an issue that happens with one user, you as a developer sitting there at your computer coding, or 10 users when you have in your QA environment, 100 users or 1,000 users, even 1 million users. You might see different problems materialize as you're at those different scale environments. And sometimes it's frankly impossible to reproduce those scale environments in even your test environments because it's just simply cost prohibitive, right? And then finally, this one's interesting. The whole process around acquiring and configuring the tools you need. I found that when people don't have problems, they're not so invested in trying to get tools for when they are having problems. And then when they are having problems, everything's on fire. We just got to use what we have at hand. We can't stop and add tools to our production environment later, right? So that speaks to the importance of having this stuff kind of as built in as possible, right? So today we're going to go through a few different themes, walk through a few different areas. The first is triaging and quickly being able to pinpoint and find issues that you have in production. And then being able to get the actual data you need to root cause the problem, and that's where we'll be using the Snapshot Debugger to look at the variables and the state of what's in the production environment. And then finally, how you can analyze performance at scale using some of the profiling capabilities. And just to sort of ground everyone in the technologies that we'll be showing today, we're going to be using Application Insights, which is our APM and analytics tool built into Azure. And we'll be showing some application map and correlation and how we can automatically collect snapshots on exceptions and the performance profiler there. And then we'll be using Visual Studio Enterprise for being able to open snapshots in Visual Studio and be able to set snap points and log points to interactively debug in the production environment. Most of this stuff is actually built right into Azure App Service, but there are solutions for working with Azure Compute, and pretty much everything we'll be showing today is supported on both .NET and .NET Core. in these environments. So with that, I'll dive right into our first demo about how we can find these problems in the production environment. So here I've got a dashboard for my application. This is a relatively simple application that I'm using to illustrate these capabilities. And I've actually pinned all sorts of different parts of my Azure environment to this dashboard here. I don't know if you're aware of this, but you can actually create new dashboards. There's the default Ibiza dashboard that you get in Azure, but you can come here and then you can create new dashboards and you can share those with members of your team. And pretty much any part that you see in the Azure portal, you can pin to your dashboard and put it here and sort of save all those things for later. So I've pinned my application map from Application Insights, which shows me the topology of my application, which layers are healthy, which layers are experiencing failures, whether it's the server or dependency calls failing. I've also pinned metrics from my actual app service and app service plan here, which is given my IaaS web server. I can see my requests and my errors over time. I can see my CPU, my memory. I can see my database DTUs. If there's any, with Azure Monitor, all these metrics are built into the platform and you can just pin them to your dashboard. And we collect these metrics from all sorts of different Azure resource providers, or RPs we call them. So if you're using Redis cache or SQL database, Kubernetes clusters, all these resource providers provide metrics to Azure Monitor that you can then pin to your dashboard to get that all-up view of what's healthy and what's not. Now, for the application diagnostics, it's very important to be able to see that logical view of what's happening, sort of that layer on top of the infrastructure. So I can go into my application map here. I see right away I'm seeing a failure here on one of these servers. I'm going to open that full application map. And here I've got some availability tests, which are hitting my web tier. And that web tier is calling SQL, and it's also making some calls to the CRM backend API. So this API here is providing some data, customer data, to my web front end. And on this application map, I can see that 100% of the calls from the front end to the back end are failing. And I can see that with this card here.
Dan, a quick question. How is this map getting drawn out? Like, how does the portal know what my resources are and how they're talking to each other?
That's a great question, Nikhil. So when you're running in Azure App Service, we have a site extension for Application Insights that automatically injects this instrumentation into your application, and it also automatically tracks the dependencies that are being called. So any outgoing HTTP calls between your services, we actually inject correlation headers so that we know, all the layers between the applications. When you have an incoming call and outgoing call, we can draw this map automatically.
You said it was automatic, so I don't have to do anything. I can just get this resource when I have Application Insights.
Right, you just have to install Application Insights and include the site extension, and then you get this data. Mm-hmm. Great. So I can click on these nodes, and now I get a list of the errors or failures that are happening on that node, grouped by operation. So I see which URL is failing. In this case, I can see that it's this call to the API visitors 3.1 path, right? So this helps me prioritize which failures I might want to look at, right? So if there's a failure, for example, in my shopping cart checkout, I know that that's something that I might want to look at right away because that's impacting revenue potentially. But if there's failure in, say, my user profile settings updated, maybe that's not quite as important, but something I should look at. And then as a developer, I always drive right into the exceptions. I always care about the exceptions. Those are the strongest signal of failure in my application. So I can see there's an index out of range exception happening here, and there's 6 of them in the last 4 hours. Actually, hold on. There, sorry, it's a Win32 exception. It was a little refresh bug there. So I click on that exception, and it gives me the obvious information, the exception message, things like that. So from this information, I can tell right away, if you've looked at exceptions like these before, you'll probably figure out that it's a bad connection string in my backend. I see some nods around the room. Actually, I had somebody on the Explo floor yesterday look at this and say, hey, it looks like you have a bad connection string. I'm like, great, it's working. Awesome. So, okay, so this is a pretty easy exception to find, but there's a few other ways I can now look at this exception here to get more context as to what's happening. And for this, I'm actually going to show you some more of the correlation capabilities that we have. First, I'm going to show you a really early sneak preview of a feature that we're working on that's not available yet, but it's very cool. There's this end-to-end trace for this operation. So if I click on this end-to-end trace for this operation here, I click on that, and it gives me all of the telemetry that we've collected for this operation from the front end to the back end, all in one correlated tree view here. So it's expanded the request here. Let me just zoom out here. And I actually get a timeline on the right-hand side, which it's not displaying in its DPI correctly. So I can see the timeline of all the operations in the application, and I can expand the front end here as well. And I can see, okay, so if I look and I walk back from the exception, I can sort of reconstruct that story of what happened, right? So let's zoom in here. So I can see, okay, this exception was thrown, and I added some logging to my application that says, hey, I'm in the data layer, I'm querying the database for user one, and then the exception happened right afterwards. So I know that my code got in there, and it attempted to make that query to the database, and then the exception was thrown. And then I can walk back and kind of say, okay, what about the server that called me? What was he doing? I can see that it got a request to this API. It said, hey, I'm in the front end. I'm going to make a query to the CRM API for visitor number one. And then it made that outgoing HTTP call. So this is a simple example, but you can imagine in very complex examples, it's very important to be able to quickly reconstruct all of that history. And how many people here have used sort of open source distributed tracing tools like Zipkin or Jaeger or some of these other things, right? So in these tools, you need to actually, in some cases, add quite a bit of manual instrumentation to your code to get this view. And again, this is just all built in out of the box. You didn't have to set up and configure and acquire and tell a bunch of developers across the company to instrument their code thusly to get this information.
Another question. So you showed that you were getting events from your back-end service and your front-end service. How are these two different events getting tied together in this view?
That's another great question. So all of these events are tied together using an operation ID. So if I look at this here, if I go back to this exception, and there's a bunch of information available on this exception, by the way. I can see the call stack. I can see the line numbers in each function for this call stack. I apologize for the scrolling here. And if I actually go and click See All Properties here, I can see that this exception has this operation ID. Now, this operation ID is shared by all of the telemetry that exists for this operation across all of the servers. So if I copy that, it gets generated on the first server that comes in. And I copy that operation ID and come back here. And I'm going to go search. So this is what you would do if you got this operation ID off the internet. And actually, in the new ASP.NET Core error page, this operation ID is presented to the end user. So if an end user calls you and says, hey, I'm getting this error, you can say, what's your operation ID? You can come into search, hit enter, and it'll return all of the telemetry for that operation. And this is what we were just looking at in that trace viewer, but just sort of in a flat search result list. So every single piece of request is tagged with that same ID automatically for you. Okay, so all this data that we're looking at, it's really important to note that Application Insights is actually powered by a really highly scalable and extremely powerful analytics engine called App Insights Analytics. So if I click on Analytics here, it'll bring up the Analytics tool. And so everything that I'm seeing in the Application Insights UI is available here for me to raw query against as a user. So often you have more questions you might want to ask of your telemetry. So this uses a Custo query language that we've created that's extremely efficient for writing sort of analytics queries. And you can build a full BI engine on top of this. So you can see all the tables in here on the left-hand side. These are all the data types that are available. So I can come in here and type exceptions. And I'm going to press Shift-Enter, which will just be a shortcut for this Go button here. And it will return me that flat log of exceptions, right? So this is what I might have had before. And, but I can start to shape this data, right? I can write a bunch of lines of queries by adding a pipe character, and then I can say, I can sort of filter it down. So I can say where timestamp is greater than 2 hours ago. So I can get the exceptions for the last 2 hours, right? And I can do, and then I can then take this, add another pipe character, and then further shape this table down. And I can say summarize count by problem ID. I can hit Shift Enter again, and now it gives me the count of those exceptions, by their exception type, right? I can do other things. I can do charting. So let's just take this timestamp filter out here. And this time I'm going to say summarize count by, I'm going to bin this into 5-minute intervals. And then, okay, so that's going to give me a list of exceptions by 5-minute intervals. But I'm going to say render time chart, and that'll turn that into a chart for me to look at, right? So I can see my exceptions now graphed over time, and I see there's actually a spike that happened, roughly 12 hours ago. And here's something really cool that's built into this analytics capability. It's automatically, using machine learning, detected that there's a feature on the graph, this spike, and it's telling me, hey, if I click on this spike, I'm going to try and diagnose what this spike is. And so what that's going to do, if I click on that, it's going to automatically try and segment out the things that led to that spike versus the things that are the other pattern. So it found 2 patterns here. One of them was this dot here, and then this below here was the normal behavior of the app. So if I click Show All here, it'll give me all the properties common to that pattern that it found. It tells me that that spike contained all of the API calls in that spike were to the get visitors 3.1 API, to this, it actually tells me they all have the same index out of range exception. And it'll tell you things like which cloud role it was, which website. They all came from one IP address. Spoiler alert, it was me in the hotel room generating exceptions. So it gives you all that information. You can tell what region it's in, if all of your exceptions are coming from the same region, or various things like that. So there's a few other cool things here. So another capability on the subject of machine learning here, let's just blow this away. I can say exceptions, and this is something that a lot of people at Microsoft find very useful, evaluate auto cluster. And so this auto cluster will run a clustering algorithm over this to tell me what are all the common buckets of exceptions here. So this will tell me that 95% of my exceptions in my application are this Win32 exception, that was that connection string bug. But there's 3.6% of my exceptions are an index out of range exception, right? So right away it'll do pattern recognition here for me. And if I expand these rows, it will give me all the properties that are common to this bucket here. It tells me, again, the IP address, the city that this is coming from, the role instance and role name. And then anything that's not common in that bucket is indicated by these asterisks here. So you can see that there's no commonality in some of the other patterns that I've found. And I can do this auto cluster on pretty much any expression. So if you have any pattern, so let's say requests, let's look at request failures where success equals false. Do that right. There, blue's good. Evaluate. Well, we see the table result here. So these are all the failed requests, and then I can say evaluate auto cluster again, and that will tell me all the APIs that are failing and what the common buckets of failures. So if you're sort of stuck with all this noise in your application, you're trying to figure out what the common patterns are, this is a great tool for you to dig into. And so that was a brief tour on analytics. If you're interested in this, there's so much power here that you can use. This is what we use for our analytics inside of Microsoft, and it's quite wonderful. All right, so I'm going to dive back to the slides here. Actually, I forgot to show you how I got all this stuff turned on. So I just wanted to share the enablement experience for app service. So I've got this web app here, Hello App Insights, which is just, it doesn't have anything turned on. If you want to enable these capabilities for your app and app service, you click the Application Insights tab here on the left-hand side, and then you can say, create new resource. What's the error here? Oh, I don't have permission. That's weird. I'm logged in as Nikhil, that's why. Okay.
Right.
Well, you click OK, and then that installs Application Insights, and then all the capabilities I just showed come with that.
Do the developers need to go add it into their code, or can you?
So a quick question about, do developers need to add it into their code? You can also add it into your code if you want to take advantage of additional SDK features for logging things or turn on extra capabilities. But no, you don't need anything in your code. This will inject the SDK at runtime. So you can mix and match both approaches. Cool.
Will it restart the application?
Yes, it will restart the application when you click that OK button.
About performance.
Okay. We're getting a lot of questions. I'd ask you guys hold the rest till the end, and then we can sort of talk about them all at once to make sure we have enough time to get through everything. Thank you. Okay. Go back to my presentation here. Okay, so what did we just see? So we saw how you could use the application map and the correlation features to pinpoint the server that's failing, and how you can use that error pane on the right-hand side to quickly drill into the failures and the exceptions that are happening. We saw how you could use the correlated tracing to get that full story of what's happening for a particular exception or failure across your servers. And then how you can use analytics and some of those neat machine learning and clustering capabilities to dig deeper into the raw data to get sort of down to the source of what's happening. All right, so now Nikhil is going to show us some even cooler stuff.
Thanks, Dan. So Dan gave us a great overview of how to use application insights to get into what are some problems or errors that might be happening in a live production service. So finding out that an error is happening and identifying that there is a problem is one thing. Figuring out what's the root cause of the error is another beast entirely, and that's pretty much what I will be talking about for this part of the demos. So while we've been talking to customers who've been trying to debug against production and trying to figure out what the root cause of their production issues are, we've heard some common stories about the ways they approach these problems. A very common story we hear is oftentimes developers don't see enough logs or don't find the right level of logs that help them identify what the actual problem in production is. In this case, they have to add additional logging statements to their code, redeploy their application, go through their entire CI/CD pipeline, and this might take quite a while to do so. How many of you have had to redeploy an app with more logs to get information? And almost everyone's hands goes up as expected. So it's a very common story. There's sometimes when we have to impersonate a customer. There's a very common, oh, it worked on my developer box kind of approach to a problem that might happen. However, customers who actually interact with the app might do weird things that cause it to break in weird ways that are totally unexpected. So oftentimes you have to go actually talk to the customer, go try and figure out what were the actual steps that a customer took to reproduce an issue. Finally, data at production is at another scale, another tier. It's quite a bit different than data that might be available in your pre-production or development environments. And this data can also cause several kinds of problems. Oftentimes we see developers having to copy down a production database into a local or QA environment to try and figure out what is happening with the data to cause an issue. So what we did at Microsoft is we actually took a video of a developer trying to debug a production environment, and it looked a little bit like this.
Looks like that's an HTML5 train, if I'm not mistaken.
Yeah, and it just keeps coming. All right, so we thought to ourselves, there has to be a better way to do these things. So our teams have been working together for quite a while now, and we made the Snapshot Debugger. It's essentially a tool that allows you to debug in production with minimal impact. And that's quite a statement to make, so I'll be taking quite a bit of time to explain how we're making that possible. The Snapshot Debugger also supports highly distributed applications. So it's meant to run at a production scale, and if you're running on 1 node, 10 nodes, 100 nodes, we should be able to support your environment. And we know that production is a very sacred environment that can have data that needs to be secure and only some people can access. So we support secure access by role. Only a developer who has the right credentials and the right authentication to access the Snapshot Debugger will be able to use it. Finally, the features of the Snapshot Debugger are present in Application Insights and or Visual Studio. I'll go a little bit more over what that means, but all in all, the Snapshot Debugger is a feature of Azure that can really help you find out the issues in your application as they're happening when they're running out in Azure. So I'll jump right into the demo and start where Dan left off on the application map. So Dan pointed out that the backend service for the application map had a 100% failure rate. If I look at the front-end service, I can notice that it also has a 1.4% failure rate. Now, I, as a developer, don't want any errors to be happening in my application, so I'm going to dig into what this 1.4% is. I'm going to click it, and I can see that there's some failed dependencies, but the thing that sticks out to me is this index out of range exception. Because exceptions, as a developer, are something that makes sense to me. Maybe I want to drill into those. When I click on the system index out of range exception, I get to the exception properties that Dan pointed out. But I also have this open debug snapshot button here.
So Nikhil, it looks like the index is outside of the bounds of the array.
That is correct.
Do you know what the problem is?
It sounds like the index is out of bounds, but I don't know why. So I'm going to try and take a deeper look to figure out.
Just thought I'd help out.
So this debug snapshot here will actually help me answer that very question. What has happened in the background is Application Insights has realized that this type of exception has been happening on the app. And on one given of a exception that happened, we captured a snapshot of your app. This snapshot contains the full process details, your stack, your locals, your heap information that allows you to drill into the entire process state when this failure happened. And all I have to do to view it is hit this open debug snapshot button.
Now, Nikhil, some of the things that you just mentioned sound like they could be sensitive information that I might not want developers to be able to see.
Yeah, great question. And I will answer it in a second after I go over how to view the snapshot and the data it can provide. So it'll take a second to analyze this snapshot. Actually, while it's analyzing, I'll just go answer that question. The way we can view this data is that a user in your organization has to be authenticated to view the snapshot. The way we make that possible is we have a specific role in Azure that if you give a user access to that role, they'll be able to view the snapshot debugging data. And I'm going to get to that by just going to my app service, and I can go to the access control here on my app services pane. And I can see that there's certain users, after it loads in the slow conference Wi-Fi, that have been granted access to this Application Insights Snapshot Debugger role. So any user who has that role will be able to access this data. So I'm going to go back to my debug snapshot. I can see it's loaded. And while I have the full call stack, I also have all the local variables that are available at the exact point of time when this failure had happened. Sorry, excuse me.
This looks a lot like Visual Studio.
Right. So what's actually happening is the Visual Studio service, a Visual Studio debugger is actually kind of running it like a service to give you this kind of call stack and local information to drill into the point of failure. While all this information is available in the browser itself, I can also download this snapshot and open it up in Visual Studio to debug against that exact problem state. So I can hit that download snapshot button, but for sake of time, I already have it downloaded. And I will go and open it. So what you do download is this .diag session file. This diag session file is kind of like a dump where it allows you to debug against the exact point of time when it was captured. It also contains all of the PDBs for your application, so you'll have the right symbols to debug against your application. So when I have this .diag session open, I can debug against that point of time with this debug with managed only button. And it will take a second and put me right in code at the point of failure where this index out of range exception had happened. So I can see at line 55 that there was a system.index out of range exception. OK. So I can see right on line 55 there's this index out of range exception. And now that I'm in my code and I can see what all is going on, I can just hover over variables, and I can try and figure out what's going wrong. And I can see that the security code is actually an empty string, and there's a split operation and indexing into an array out of the split that is actually causing the system.index out of range exception. Now that's really weird because, first of all, I shouldn't have an empty string in my app, and second of all, it's bad that I'm doing this kind of indexing without any kind of catching or kind of way to recover from this error. So I have a pretty good idea of what I can do to try and fix my app to make sure that my security code is a valid string and make sure I do that in my application to prevent this kind of exception from happening. Now, in a nutshell, Application Insights has pointed me at this error and allowed me to debug at this exact point of time. The Snapshot Debugger also allows me to interactively debug with my app with two features called snap points and log points. Now, I might want to do this to try and figure out how these security codes are getting set. I, as the developer of my app, I'm only using this security code internally in my application, and the fact that something or someone has set it to an empty string seems a little bad, so I want to try and figure out what's going on. What I can do to use the Snapshot Debugger and use snap points and log points on the app is, first of all, get out of this view. And I can go to the particular app running my code. Right now, it's ASP.NET app that's deployed to an app service, and I'm going to quickly bring it up. It's this app right here. If I want to debug against it, I can right-click the app in the Cloud Explorer and attach the Snapshot Debugger. So what Visual Studio will do is it will go out and connect the Snapshot Debugger to my application as it's running out in Azure App Services and put me in a mode that looks a lot like the debug mode, where I have my modules loading up, I have my call stack, I have my locals, I have that kind of information that I can view at a glance. So in my application, like I would set a breakpoint in local debugging, I can come here, and on a certain line of code I'm interested in, I can set a snap point. Now, a snap point is vastly different than a breakpoint. A snap point has been built from the ground up to be able to be used in a production environment. And the way we make that possible is that the snap point doesn't actually stop the application at that point and allow you to debug. What it does is it quickly captures a snapshot of your app, which allows you to drill into the debugger information, your call stack of variables, but the app keeps running. Any live traffic or live requests coming into the app see almost no difference at all. To use this snap point, what I can do is I can hit the Start Collection button to turn it on. And now any request that's hitting that code path in the app, like this Save Change button, which will hit that Update Controller, will capture a snapshot in Visual Studio. So to view the snapshot, I have to just double-click or hit the View Snapshot button, and it'll take a second or two to load up.
So is your website still active while you're doing all of this?
Great question. So I'm opening up a snapshot, I'm analyzing what's going on, but at the same time, the website is still live. It's still serving out any requests that are coming into the site. And the way we make snapshots possible is in the background, we're essentially just forking out the process that's running your code. And this fork is created in about 10 to 20 milliseconds and takes on the order of hundreds of kilobytes of memory on your disk, but it does have a little bit of commit charge. So this fork process, when I debug against it, I am put in code exactly at the point of where I have taken my snap point, and I can see my autos, I can see my locals, I can see my call stack, and all the debug information at this particular point in time. Now, if I'm trying to drill into this visitor, I can just hover over it like I would in the debugger, drill into the visitor, and I can see that there are actually security codes further back in my app when updates are being made to specific visitors. Now, that's something that, again, I need to handle in my app, that security codes shouldn't be a property that is set and used and modified at will, maybe by update requests coming into my app. So that's a point that I can take back and try and fix at a later point. So this snap point has allowed me to identify that. Sorry about that. While I might not be able to make the code change to secure against security codes quite yet, what I can do is I can use a new feature called log points to actually log whenever there is a security code being set by my app, so I can take a closer look at those visitor IDs and that kind of thing. So what I can do is I can come to a snap point, and I can go into the settings here. So a quick point here about snap points is a lot of the things that a local debugger can do, like set conditions on breakpoints, can also be applied to snap points. So in these snap points, I can actually set conditions if I'm interested in a specific case when I actually want to debug. If I have hundreds of requests coming in my app, I can specify a condition that might let me narrow down into a specific request that I can then capture the right snapshot that allows me to debug against maybe a small set of problem requests out of a large set of working requests. So the other thing I can do is, in this snap point, instead of capturing a snapshot, I can take the action to create a new log message. In this log message, essentially I can type out any new information that I'm interested in logging out in my application. In this case, I want to say something like, visitor has security code. And in this log message, I can also evaluate out a variable. So I can say visitor ID was visitor .visitor ID. And I have a nice IntelliSense experience if I want to get into a specific field and evaluate it. So I've created this new log message, and essentially I can send these logs to two different places. One, I can send it to the output logs. What this will do is it'll essentially capture all the new log messages that are in my app and stream them down into Visual Studio for me to see live as they're happening. Two, I can send it to the application logs. What that will do is, essentially in the .NET framework, it will make a call to system.diagnostics.trace. I can then have a listener that can pick up these logs and propagate them to wherever my application logs are going. I'm using Application Insights, and I'll show you how to query those logs with Application Insights in a second. So I'm going to turn this log point on with this update collection button. Sorry. Now, when this particular line of code runs in my application out in production, what I see is log points coming into Visual Studio. Now, these log points reflect the new message that I've inserted into my app, and I've been able to insert this new log message without having to make any code changes or redeploy, and they just start appearing when that line of code has been run. So not only are these particular logs appearing in Visual Studio in the Diagnostic Tools window, But if I come up to, sorry, 1 second, it looks like I closed the portal page I was supposed to be on. Oh, just kidding, I didn't. If I come up onto the analytics portal, I can actually query traces, which is where I'm setting my application logs to right now. And I can see that any additional logs that I've taken also start appearing here. And I can just requery traces. These were the ones I did yesterday when I was practicing the demos. I can see the new security codes, the new log messages starting to appear in my application logs where Application Insights is holding them. I can also use any of the features that Dan showed earlier to cluster up the logs, drill into the logs in the analytics portal, and to actually categorize and use these logs in any way I will. So, sorry. All the magic of the Snapshot Debugger, essentially whenever you hit the stop button, it will go away. All the logs, all the new log messages that you have set, all the snapshots that you've taken, as soon as you hit the stop button, we will clean ourselves up in your app and essentially close out any snapshots and remove any new log messages what we've inserted into your app. So I'm going to go a little bit over how we make the Snapshot Debugger as efficient as possible and kind of the technical details as to what makes it feasible to be used in a production environment. So the first thing what we do is that we support multiple instances running on your app. In terms of the snapshots and exceptions, it doesn't matter if exceptions are happening on one node or node 100, we'll be able to capture out that snapshot and give you the diag session files. In case of snap points also work on a multi-instance environment, and I'll go over in a second how we make that possible. So another thing you can do is in your application itself, while you set snap points in your code, you aren't allowed to actually step from those snap points, but the way you can kind of get around that is to set multiple snap points throughout your code and turn them all on at once. So if you have multiple snap points throughout like a specific function and they're all turned on at once, we'll make sure all of those snap points are capture data based on the same end user accessing your site. And we take care of all of the work to make sure that the snap points are correlated and they reflect the relevant data that actually makes sense from a transition from one line to another line to another line. As I mentioned briefly earlier, snapshots are created by a process called process forking. Now, what we're doing is essentially we're creating a fork of the W3WP process that's running your application. And this forked process, we're not actually copying the full process. What we're doing is we're copying the page table. And essentially we're setting the pages to copy on write. So whenever a page gets written into and variables or values change in your application, we're then copying that changed page. This allows us to have an extremely minimal impact in a production environment. The fork processes take up about 10 to 20 milliseconds to create and on the order of hundreds of kilobytes of memory while they're alive. We've done some pretty extensive load testing and that kind of thing on live applications while snapshots are being generated. And we see almost no discernible difference in the application with snapshots and the application without snapshots. And an important point of the log messages are while you can evaluate variables, you can look into properties in the log messages, the log messages themselves are only virtually executed. So they can't actually affect the state of your main application itself. We virtually interpret what the log message output is, and that log message can then be propagated, again, back to any store or back to Visual Studio. There's a caveat of this. If you want to have some native properties in your application, these native properties might not be accessible by the log messages. And finally, we've done a lot of work to make the Snapshot Debugger work really efficiently on release-built binaries. If you debug against managed code that's built for release, today you might notice there's a lot of problems or a lot of difficulties in debugging release applications. Some of these might include that variables don't exist or you can't set breakpoints at certain lines. We've done a lot of work to make these problems kind of go away in snapshot debugging. The way we achieve this is locations that take snapshots, either by snap points or automatic collection. We temporarily switch the function that the snap point is set in back to the debug definition of the method. Now, that allows you to get into any line and essentially the problems of variables not existing or lines not being able to set snap points on goes away. So I mentioned I would talk a little bit about how snap points work in multi-tier, multi-node environments. And the next couple slides are a quick overview of that. When you're debugging locally, it's a pretty simple problem where you might have one client and one server, and you as a debugger might be debugging in the server end, and you're dealing with like a small number of requests coming in from the client, who's usually you. In production, that's a little bit scary because there's hundreds of clients, there's hundreds of servers, and it's just a much different scale of environment that you actually have to debug against. The way we sort of deal with that is when you set snap points in your code, we actually turn them on everywhere, on every server instance every server that's running an instance of your app. Now, basically, based on the conditions that you set on the snap point, we'll only focus on the first server that hits the first snap point. And essentially, that server is the one we'll focus on for any of the additional snap points that you've set in your code. Now, that sort of solves the problem because now you're only dealing with one server, but there could still be multiple clients that are hitting that server. The second level of filtering that we do is we also focus on the one client that is hitting that server. And we do that using the operation ID that Dan mentioned. And essentially, we make sure that all the snap points you've set in your code get captured for the same operation ID. So you can then switch around between multiple snapshots and see the transition of state in your application between multiple lines of code. And as you can see, this becomes a lot simpler problem and allows you to get a lot closer to your local debugging experience out in a production environment. So in recap, we've gone over quite a few features. We went over using application insights to automatically capture snapshots when exceptions have happened in your app. To use this, there's a couple of things you have to set up. You have to add a NuGet package into your application, as well as use the Snapshot Debugger extension to view snapshots in Visual Studio itself. The automatic capture experience is in public preview. You can access it at this link down here, aka.ms/AI Snapshot Debugger. We also went over snap points that allow you to interactively set snap points in your code and capture snapshots to debug against, as well as log points, where you can capture additional log messages in your app and propagate them back into App Insights or into any log sort that you have. Snap points and log points are also in public preview today. You can get started with those at aka.ms/snappoint. So now that you've dealt with problems that might be happening in your app and sort of debugged into them, the next thing that you might want to look at is the performance of your application. I'm going to be passing it back to Dan to give a good overview of how to deal with performance in your applications at scale.
All right, thanks, Nikhil. Let's hear it for snapshot debugging. Come on, that was awesome. Okay, everyone that's clapping, I want you to go try out the features and then email us afterwards and tell us what you think, okay? Deal? All right. Now that, again, as Nikhil said, now that you've got the application functioning correctly in production, often performance kind of comes as a second level thing. So I'm going to ask a question. How many people here have ever started with a timeout exception in an application and then had to drill into the performance or figure out why it's so slow, right? Lots of hands, right? So that timeout exception is sort of the key thing that people usually deal with, but you can also do a lot more proactive performance tuning of your application to get better user experience and things like that. So I'm going to be talking about some additional tools that help you when the performance issues aren't so obvious in your production application. So again, why do we care? Why do we care about optimizing performance? If the application's not failing, why is it important? Well, the key thing is to first deliver a great user experience. I'm sure many of you read the numerous studies about improving your application load times can increase user engagement with your application or site and lead to better revenue and customer satisfaction. And ideally, you want pages to load less than 500 milliseconds. And if it's less than 100 milliseconds, that's practically instantaneous to end users. So usually you look at your API calls, and you want to try and make sure that your API calls are at least returning faster than that, because then you want to leave a little bit of time for the web browser to do its work. And the other important thing is to minimize the overall cost of your cloud resources, right? So you might be able to deliver 500 milliseconds or less response time of your application, but you might need 100 servers to do that, and that's going to be cost prohibitive. So how do we get it down to 50, 20, 10, so that you can deliver more functionality with those additional servers to delight your users? And for both of these goals, the thing that I like to recommend people do is to overall minimize the amount of times code is spent doing stuff, right? When code is running, it's either using some cloud resource either on the server itself or on the database or something like that. It's utilizing resources, right? So if you just minimize the amount of time it takes to respond to a request, you're improving the user experience and minimizing cloud resource usage. So I have this very kind of simple model of what the lifecycle of a request is. It's simplified, but it's very useful, I find, to illustrate kind of the approach that you can take to optimizing performance, right? So if you look at the life of a typical request, there's some time at the start where network activity comes in, and then some server code runs that then takes that input data that was passed over the network, decides what to do with it, and then usually makes a series of dependency calls, either calling out to a database or HTTP or maybe another caching server or any number of different servers. And then it gets the results back from the database or other servers, and it runs a regex over the data or runs a link query to then process it, and then returns that to the user, which then takes more network time. So the point I wanted to make is there's two main categories of time spent in executing a request. Either you're waiting on something, I/O, external resources, database to return, or you're spending time executing code on the CPU on that server. So overall, you're either using resources on your server or you're using resources on another server somewhere else when the request is running. All right? So what does this look like then when another request comes in concurrently to that same application server? So while you can do dependency calls or other things concurrently, only one request can really be using a CPU at a time. So if you've got a lot of requests using the CPU, then it starts to become a resource bottleneck. And if you see here, again with this simplified model, while the first request is processing those inputs, the second request might have to wait to process those inputs before it can sort of execute on the CPU. And so that's going to start to increase the overall latency of the application. So what are some scenarios or examples of this in the real world, right? So there's two classes of issues, either performance issues that affect every single request. So every user that hits your home page is going to see these database calls and these things happen in the back end, and that's always going to take about 500 milliseconds. And you might want to get that faster, right? And some common problems that you have are maybe Entity Framework is doing a bunch of bookkeeping, or just the link query that you're running is super expensive. You might have CSHTML rendering, or a sequence of blob storage, database, or HTTP calls. And then there are performance issues that happen more infrequently, but may sort of inconvenience the users that experience them, either because of scale or because of various conditions that only occur randomly. So this can be resources get temporarily overutilized because there's a spike in traffic, or there's a garbage collection that runs to clean up a bunch of memory and everything sort of starts hanging. Or there can be resource contention, either CPU, disk, memory, or even contending on various locks that you've set in your application to synchronize data structures across multiple requests. So to address this, we've built the Application Insights Profiler. And so the goal of the profiler is to help you see what your code is doing over time. And it does that by capturing data from your production environment. And it actually, it runs for 2 minutes out of every hour. And it captures everything that's happening on the application server during that time. Now, some other profiling approaches only sample 1 or 2 requests that are always on. This approach allows you to see everything that's happening in your application. So it captures all the requests that happen during that time, the fast ones and the slow ones. And we store this data in Application Insights at no additional charge beyond what you may be paying for Application Insights already. So there's no additional cost for using this. And then we take all that data and we segment the results into percentile buckets so that you can see what does a typical request look like and what does my long tail or 95th percentile request look like. And that allows you to sort of get to those 2 classes of issues that I was mentioning earlier. So with that, I'm going to show you what this looks like. And I just need 1 second here to get my app open. Okay. So I'm coming back to my portal here. And for this, I'm using a different application called Fabricam. So let me just show you what this application looks like. So this is a demo application that we've had around Microsoft for as long as I've been at the company, actually. So I thought, this is a fun application. Usually I go in and I add some performance issues into an existing application, put 4 equals I from 1 to a billion to show there's a CPU bottleneck. But this application's been around for so long that I said, you know what? There's got to be some easy performance problems that I can solve with the App Insights Profiler for this demo. So we've got our pages here. We've got our tickets page, which kind of takes a little bit long time to load. The home page is okay, not too bad. And then our customer details page actually seems to be quite fast, right? So let's take a look at what Application Insights can tell us about this. This is just my experience. The users of my application might have different experiences than what I'm seeing here. So I'm going to go into my Application Insights resource for this, Fabricam Exemplify. And first thing that you can do in Application Insights, there's this server response time. This gives you the average server response time of your application over time, tells you what your APIs are doing, things like that. So you can either click on this graph right here. So if you click on this graph, it takes you to the performance page in Application Insights. You can also get to performance just by clicking on performance from that left-hand menu. So one thing I want to point out, we've just released a complete revamp of this performance UI in Application Insights. So it's a lot more powerful than it has been in the past. Let me just zoom out a little bit. And so what I have is I get that same average request response time over time here in the top graph. This is graphing the overall. And I can also see my request count at the bottom. I can see spikes in traffic, right? So these are I'm running some load tests on the application, and you can see exactly where those are. And then I can also look at CPU and other metrics. So I can see what does the CPU of my server look like over time. So I can look for spikes in CPU. It's very common where there's random spikes in CPU in your application, and you don't know why. So from this, I can also drill into particular operations. So I've got the home index page here. So if I click on home index, that's actually going to give me, if I select that on the left-hand side, it'll filter the right-hand side to that operation. So this gives me here a distribution curve or a latency profile. It tells me this is not over time, this is the duration as the x-axis here. So it lets me see what does the cluster of my requests look like. So I can see there's a grouping of requests that are around the 8 to 42 milliseconds here, and I can see that by looking at the value on the graph as I'm hovering. And then I can see there's a cluster of requests that take between 460 to 1 second worth of time there. So that usually, when you see these spikes in these graphs, these can often represent distinct performance issues that are happening in these requests. And you can actually zoom into this part of the latency curve. So if I want to look at the requests along here, I don't want to look at the slow ones. I want to look at these sort of faster ones. I can kind of drill in there. Also, there's a little handy selector here that lets me drill into the 95th percentile. So if I click that there, that shows me that the 95th percentile to the 99th percentile is over here. Okay, so from here, there's a bunch of insights that are presented to you about this group of things. So it shows us all the common properties that exist for the applications in that cluster that I've selected. And I can also look at individual samples, but I can also look at the profiler traces. So it says it's collected 2 profiler traces for this part of the curve. So if I click on that, it'll open up the profiler, which will then give me sort of a list of samples and all the percentile buckets here. But then I can drill in and look at the profiler trace. So on the left-hand side, it lets me pick individual traces, and on the right-hand side, it shows me a timeline of that trace, and it tells me all the code that's executing over time.
What am I looking at here? Is it a call stack, or what's this when column?
Okay, so everyone knows call stacks, right? So what happens when you have multiple call stacks? Your code is changing over time, right? So you need to sort of take all the call stacks and put them on a chart that go left to right so you can kind of see how the call stack changes. And so when we do that, we actually get a call tree, and then that timeline chart is on the right-hand side showing you when each call stack was active over time. So here, I can see that that the overall request took 1.8 seconds. That's what the duration column tells me. And if I expand that, it tells me that of that, 900 milliseconds was spent in block time, which I'll talk about later. And then 208 milliseconds was actually spent in beside the MVC application begin request method, right? And then,
so that method is only running for that little blue duration on the when column?
Yep, that's exactly. So this is when this particular call stack was active, right? And so if you take each row here and you walk back up, that's the call stack, the thing along the diagonal, if that makes sense. And then you can see when that was active there. So it's actually very common at the 99th percentile or your slower requests that there's going to be some weird condition happening in the operating system where you're blocked on disk resources or things like that. And here I can see my user code, but I can see that the time really isn't spent much inside of my user code, and I might need to see what's going on. So I'm going to click this Show Framework Dependencies button, which is actually going to show me the full call stack, down to native code, down into the operating system, for those particularly nasty problems where you need sort of that deeper insight. And this is all being powered by ETW traces. So if you're familiar with ETW tracing tools, either Purview or Windows Performance Analyzer, you can actually download these ETL traces and then open them with other tools. So I'm going to scroll right down here, and remember we saw that trace right line. Where is that trace right line? Okay. Let's keep going. A lot of stuff happens in the framework that you're not aware of. Search might be useful, yes, that's a good point. So the point I wanted to point out here is that with the full call stack, you can actually start to root cause issues that are very difficult. So here I can see that I spent 900 milliseconds as part of this request in this file existence cache looking to see if there's files that exist. And if I keep scrolling down, I can see I'm actually waiting on this SMB dispatch function. So this is actually, SMB is the network share sort of logic. So I can see in this request here, I'm actually context, so this swapped out on a context switch. And from here, I can see I'm spending time waiting for an SMB share to be mounted on my server, right? So this is really, like you would not be able to tell this just from looking at your application code alone. So that's sort of an example of the depth here. You can tease out from these call stacks things like spending time waiting on DNS or network send receive, all sorts of things that might be happening in the operating system. Now let's look at a more typical request, because that was something that happens not very frequently, but it's something that we should be aware of as we're looking at our long tail. So, let me hit a little bug here on this particular request that had a bunch of exceptions being thrown. Okay, so this CSHTML execute. Okay, let me skip this one. It's not happy today. Let's go ahead and look at our service tickets index page. So if I look at the profiler traces for this page, it actually gives me, we can actually see, so this is a more normal request, and we can see that we're spending a lot of time rendering CSHTML, and I can tell that from that CSHTML execute page. And if I look at this, it says some of that is in handle entity, shaper handle entity append only here, and if I expand that, it says 100 milliseconds of that was spent in CPU time. So remember, CPU time is bad for scalability because only one core can be using the CPU at a time. So this is limiting my requests per second to about 10 requests per second or less because of that 100 milliseconds of CPU. So I've been working in performance a long time, and what I do when I see something like this is I go into my search bar and I type the name of the function and I put the word slow beside it and I hit enter and I see what I can find on the internet. So usually when you hit performance issues like these, somebody else out there on the internet has also hit an issue like this. So I found this blog post. Again, this is a real problem that I found in this application. And if you kind of read through it here, it turns out that this is related to change tracking in Entity Framework. So when Entity Framework retrieves a query, anytime you access the objects, it does a bunch of bookkeeping so that if you change those objects, it can then save it later to the database. But this is a read-only query. So in this case, I'm not actually saving anything to the database. I don't need that change tracking. And actually, it turns out this is quite a common issue that people run into. So to fix that, I can just go into my database context where I return that and just add as no tracking. And so this will save me on all of that cost of that change tracking. So that was a very subtle issue, but now I can scale my application much better. Okay, so let's look at quickly one more problem. We got time for one more. If I come and look at this customer ID method here, I can see that I've got some of these here that take up to 600 milliseconds, although quite a few of these return in only a handful of milliseconds here, 10, 20 milliseconds. So I'm going to view the profiler traces again for this API call. And if I look at this, it actually tells me automatically that this request took 400 milliseconds, but 80% of that time was spent in lock contention. And if I show here, it tells me that this lock contention was in the customer repository.find method. And if I go into my customer repository and go to find, you can see that, it looks like Nikhil does not have the latest version of this source code on his machine. So what the problem was that I actually had a lock statement around this piece of code, which would only allow one request at a time to enter this function of the code, right? So this was basically serializing all of the requests out to the database. because I was locking around this method. So when only one user is accessing it, it's very quick. But if you have multiple concurrent users hitting this line of code, they all start to queue up and back up behind each other, right? Okay. So getting back to the slides. So the way you turn this on for Azure App Service, you can go to the Performance blade, click Configure Profiler, click to turn Profiler on, and this will start that sampling. This is generally available for Azure App Service, and we do have a preview available that allows you to enable this for compute, VM, Service Fabric, VM scale sets, cloud services, and things like that. You can prioritize the operations to look at by looking at the percentiles. And then you can drill into example requests and see where you're spending time executing code in those sample requests using that call tree on the right-hand side and that execution timeline. And it breaks it down between CPU and block time on the leaf nodes there. Okay, so some things that I hope you can take away from this talk is that these diagnostics are built into .NET and Azure. Most of the things that we show you kind of are transparently built into the runtime or Azure App Service or other things. And then these code-level diagnostics will really help you to minimize time to issue resolution because it provides the developers with the insights that they need to understand the root cause of the problem without having to first reproduce it in their own environments. And then as you have issues with more complex topologies, more services talking to each other, especially as you move to microservices, the correlation and application map features will better help you understand what's happening in those, with those problems because you can see that full story from front end to back end all the way through with all the traces correlated. So some things for you to follow up on, some helpful links here. If you want to try out the automatic snapshot collection on exceptions with application insights, you can look at that first link. Then you can try out the snap points and log points preview at that second link. More information about the profiler is on the third link. And if you'd like to get updates from us or get in touch with us, we have a quick survey for you to take out there at that fourth link. Tell us what you're interested in. We'll reach out to you. We might ask you some questions about how these features can work in your own environment.
Yeah, if you're interested in any of these features, please fill out the survey. We're more than interested to talk to everyone. And a lot of these features are built with direct feedback from you all, so you all make all of this possible.
We're getting towards the end of the conference, but here's some other Azure monitoring related sessions that you might be interested in. And while I put up this evaluation reminder, we have about a minute for questions. I'll answer the one question that we had earlier about the performance overhead of injecting the SDK. I believe when we do the SDK injection at runtime, it does turn on the profiling APIs, which will have some startup time slowdown for your application, but overall it should be less than 1% overhead to your app. Yep. Go back to the previous slide, okay. Yep. Question here?
Yeah, hi. When you first pulled up the, I think maybe the Snapshot Debugger or one of them, you got a little warning that said the application version is different from what's deployed. Is it up to the developer to load the right version from source control, or is there some way to automate that from VSTS?
Great question and great awareness to notice that. So yes, right now it is up to the developer to load up the right version of the source code. We are investigating ways to kind of automate that process, but for right now you have to get the right source files that are corresponding to production.
We do have the PDB files, which is the thing that, if you have the source, will allow you to do the mapping. And then we just have time for one question here. We can talk to anyone else after the talk down here. Yep.
My question is about how does this integrate with log analytics? I could see the UI is the same, except the label is different. So I get all of these new SQL intelligent insights into log analytics. So can I use both, or how do I do it?
Actually, great question. So the app analytics, log analytics was just re-platformed to use the same backend database and query engine. So over time, you'll see application insights be able to use a log analytics instance. Log analytics is something that you can purchase if you just want the analytics capabilities and don't need all the other UI with it.
Yeah, so can I use them both together, or should I write to application insights?
If you want all the APM stuff, I would use application insights. And then in the future, you'll be able to use them together. So,
over time, they'll converge.
Yes, that's the plan. All right. Thanks, everyone, for your time. Anyone else that has questions will be here afterwards. So thanks.